Now to go over the hyperbolic tangent function, the hyperbolic tangent function outputs values in a range from -1 to 1, as we see over here, making it zero-centered, which can help with the convergence during the training of neural networks, which means reducing the chances of error between the different outputs during the training process. So it helps with convergence, reducing the error during training for neural networks. And this function behaves much like the sigmoid function when x is near 0, as we see with the S-curve. But as x moves away from 0, the hyperbolic tan function approaches to -1, as we see, for negative values, and 1 for positive values, more sharply than the sigmoid. This steeper gradient can lead to faster learning in the early phases of training, but much like the sigmoid function, the hyperbolic tangent function also suffers from a concept called vanishing gradient. A little side context, may suffer from vanishing gradients. For vanishing gradients, basically have smaller values as they are approaching closer to a specific value that we have on the y-axis, and this could lead to slower learning if the gradients are very small, since during the training process weights and biases are constantly updated throughout the training process, hence the term convergence. And as a result from slower learning, this would actually have not that much of a significant change between the weights and biases, making the training process extremely slow. So slower training. And also a bias towards recent data. Where vanishing gradients can cause a model to have a short memory and it fails to propagate learning signals back to the earlier data points in the sequence, and just in those contexts as well. But to be able to go over the formula for the hyperbolic tangent function, is that the hyperbolic tan function, typically we have our symbol, tan h of x. Then we have the Euler's number that we already know. So we have E, Euler's number. Then we have x as our input to the function. Hyperbolic tan function. There we go. And overall, much like the sigmoid function, the tan function operates as a unique way to be able to train neural networks as well. So let me just zoom out of here and feel free to take a screenshot. And so yeah, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you have any other questions, feel free to put it in the comment section. And as always, take care. Cheers. Bye-bye.